13.5 probability models and 13.6 conditional probability formulas. Alright, we're just going to jump right into examples. Use the two-way frequency table to calculate the probability that the person is a Democrat given the fact that the person supports the issue. So P, Democrat, given, whenever you see this line here, that means given that they support the issue. Alright, so whenever you are given something, that changes the number of possible outcomes. So normally, the number of possible outcomes would be 118 because that's the total number. But here, we are just considering the people who actually support the issue. The total number of people who support the issue is 52. So this is going to be your bottom number. Now, within this, how many of them are Democrat? 24. So, the probability of selecting a Democrat from the people who support the issue is 24 out of 52. Now I can divide this by 4. I'm going to get 6 out of 13. And they want a decimal rounded to the nearest hundredth, so this is going to be 0.46. Alright, next example. The table shows differences in political ideology by education for a random sample of voters. Use the data to solve the problem. Find the probability that a randomly selected person from this group is conservative given that they have attended college. So, probability of conservative given attended college. So, remember, the given part is the bottom number. So, we're looking for the total number of people who have attended college. Looks like it's 18 plus 16 plus 8. If you add those up, you get 42. Now within just those 42 people, how many of them are conservative? 8. So I have 8 over 42. I'm going to divide top and bottom by 2. Sorry, there's a little bit of a lag. 8 divided by 2 is 4. 42 divided by 2 is 21. They want an integer or a simplified fraction, so 4 over 21 is the answer. Okay, conditional probability formula. This formula is kind of what we've been doing already, but it formalizes what we've already kind of figured out. For any two events A and B, the probability of B occurring given that event A has occurred is probability of B given A, the probability of A and B over the probability of A. And this is only where the probability of A is not 0. Okay, a jar contains 11 large red marbles, 5 small red marbles, 7 large blue marbles, and 6 small blue marbles. If a marble is chosen at random, which is the conditional probability, or which of the conditional probabilities is larger? P red given small or P small given red? Alright, so first let's calculate P red given small. The number of small marbles is 5 plus 6. So my bottom number is going to be 11. And the number of red marbles, the number of small red marbles is 5. So the probability of me drawing a red marble, given that the marble is small, is 5 over 11. Okay? Now, the probability of me drawing a small marble, given that it's red, well, there are 11 plus 5 marbles, so 16 marbles, and 5 of those marbles are small. So it looks like there is a higher chance of me drawing a red marble given that it's small, because 5 over 11 is bigger than 5 over 16. Okay, last example. 30% of the library books in the fiction section are worn and need replacement. 20% of the non-fiction holdings are worn. The library's holdings are 60% fiction and 40% non-fiction. Find the probability that a book can be chosen at random from this library, or that a book chosen at random from this library is worn and needs replacement. Okay, so this is what's going on. Of all the books in the library, 60% of them are fiction, and 40% of them are nonfiction. Within the fiction section, 30% of them are worn and need replacement. That means 70% of them do not. But that's within this 60%. Within the 40% of nonfiction, it says that 20% of them are worn and need replacement. That means that 80% are not. Okay? So we want to know that what's the probability of a book being chosen at random from this pile or this pile. So what I need to find 0.6 times 0.3, and this is because I have 60% times 30%, so 30% of 60% or 60% of 30% is 18% or 0.18. 40% times 20% is 0.4. Times 0.2. Which is 0.08. So the chances of me getting a fiction book that needs replacement is 18%. The chances of me getting a nonfiction book that needs replacement is 8%. I'm going to add those two percentages together, and I get 0.26, or 26%, but in this case they want a decimal, so my decimal is 0.26. Alright, and that's all the notes for today.